Hi, and welcome to Engineering with Rosie Live. I've actually just been talking to myself for the last 15 minutes. So, that's one of the fun parts of the live stream, not really getting the feedback that I need. And echoey, it's very disappointing because I have my fancy new microphone. Okay, anyway, let's get right into it. Sorry, I'm really sorry that I have I've kept you waiting for so long. So anyway, I'm sure that as I keep going with the live streams, then I am going to get much better at it and not have these kind of hiccups again. But basically, the reason why I wanted to start live streaming was to be able to cover the topics in a more casual way and also to be able to be a little bit more critical about some of the kinds of new energy technologies that we see covered in the news and on YouTube. So that's my plan for these. I'm going to be analysing clean energy technologies that are in the news. I'll be looking at their strengths and weaknesses of the design concept, always from an engineering perspective, obviously. Comparing to existing and past technologies, because that's something that I think we don't see a lot of with new technologies. And I'll also be looking at the company's claim and critically assessing those claims. And of course, answering all your questions. So I just want to start with some disclaimers that this is just my opinion. I'll tell you always what information I have used to generate my opinions. But in case I have made a mistake, then I always welcome whatever company that I am talking about. Please get in touch and I'll do a correction in the next episode. So definitely always going to offer a right of reply. And obviously everybody makes mistakes and we can learn from those by having the feedback. So that's another benefit of the live format, I think, is it will allow a lot more of that kind of, dialogue and increase our understanding gradually. So the live streams are sponsored by WeatherGuard Lightning Tech. They make a retrofittable lightning protection system called Strike Tape, and I'm really excited to have them as a sponsor because one, they're a great engineering company, and we already are talking a lot about wind energy and other clean energy news on a podcast that I am co-hosting with them called the Uptime Podcast. So you can check that out. I put the link in the description. And you can also sign up to get their weekly tech newsletter. I'm also really excited that I got them as a sponsor because there's no conflict with the kinds of topics that I talk about. I mean, you can imagine if I was sponsored by like Toyota, say, and then I'm trying to objectively say whether I think that hydrogen cars are a good idea or not, then that would be a bit weird. So it's really, really great to have WeatherGuard on board, and thank you very much to them. Okay, so let's just jump right into it. Today's topic is a Vortex Bladeless wind turbines. I did a poll on YouTube, but you can't put a picture and a official poll together, so I had to use my very scientific data management system there. But the answer was that you wanted to see Vortex, so you can see that there. For those of you who haven't seen it before, it's a really unusual concept. And I think that that's why it's really captured the imagination of a lot of people. We've seen it heaps in the media. Lots of other YouTubers have covered it. I just wanted to find, So I've seen lots of articles like this. So the future of wind turbines could be bladeless. This is obviously a different shaped version covered in wide as well. Okay, so I'm going to be talking about their Tacoma model, which is 2.75 meter tall. Sorry, I just seen a comment. I can put them on the screen, actually. Was that a little shade at a particular science tuber? It wasn't at a particular one. It's a general comment that I think, that video. No, I did see that one, and probably subconsciously that was a little dig there. But in general, I do just think that on YouTube, people talking about science technology are way way too enthusiastic about every single new technology that we see. And so, yeah, that's part of the reason why I wanted to be a bit more critical, or not critical, but just rigorous, let's say. Okay, so yes, I'm going to just show you. They have this really great technical paper you can get on the Vortex website. So yeah, it's this one, and it's got so much information. If you want to design your own competitor to Vortex, then this is where you should start, because they basically give you all the information that you need to understand the phenomenon. Yeah, so their Tacoma model is their biggest one at the moment. It's 2.75 meters tall, and the moving part of it is 2.15 meters. I emailed the company, and actually their CTO, their chief technology officer, did email me back with like a lot of answers. So I actually really want to thank him for that, because that is a lot of really good detail. But he told me that it oscillates about 4.7 degrees either side. I think that's at the maximum wind speed, because the oscillation does increase as the wind increases. Yeah, so you get a swept area of about 1 square meter. Here's the power curve. So at 11, the rated wind speed is 11 meters per second, and so you get 100 watts at that speed. So it's a small wind turbine. Yeah, and as I mentioned, as the wind speed increases, the swept area increases. So for a normal wind turbine, that swept area stays the same, and the power increases with the cube of the wind speed. But for the Vortex, you get more swept area the higher the wind speed. So you're going to get like an even steeper power curve for the Vortex. But it does have a cutout wind speed of about 12 meters per second at the moment. And I was told that what's really tricky for this design is to get a really wide range. So they have to, maybe I'll come back to that, because I want to talk more about how it works. So yeah, so basically we're going to just head over to Wikipedia University now, and we'll see vortex shedding. So basically air flows over the cylindrical shaped device, and then vortex sheds out the back. And the way that it happens is you kind of see this like oscillating action. So it on one end, it's going to push the generator one way, and then at the other side it pushes it the other way. And if you can get the frequency of this vortex shedding to match the natural frequency of the device, then you're going to get resonance. I think I've got a video of the Tacoma Bridge collapse, which is apparently what inspired the founders. So when you have the frequency of the vortex shedding matches the natural frequency of the device, then you can increase the amplitude due to resonance. So resonance is the same reason why how musical instruments work. And it's actually interesting, because usually when you're designing wind turbines, you're aiming to avoid this issue of resonance. So the wind turbine blade has a natural frequency, the wind turbine tower has a natural frequency, and you really want to be careful to make sure that those aren't going to match like the frequency that the blade passes the tower, because then you get resonance, you excite the thing, and you'll end up with structural collapse. So that's one really interesting feature about this Vortex Bladeless design, is that it's taking a phenomenon which normally we're trying really hard to avoid, and they're harnessing it. Okay, so next I want to show another video that shows the inside of how it works. So let me, so this is a computer rendering, and then in a second it's going to go transparent, so you can see how it's actually generating electricity. Yeah, so what you can see inside there is their special alternator, and it works similar to how it's like the Faraday's law of induction. When you have a magnet moving in when you have a moving magnetic field, then it's going to induce a current. Yeah, so you can have a look at the whole video later, but basically it works similar to those shaker flashlights. If you've ever seen them, they put some coils of wire and shake a magnet in the middle, and so you get this changing magnetic field and you induce a current. So, I mean, that's my understanding of how this this system basically works. But I think that by far the most secretive part of the technology that Vortex have is their alternator, and I think that that's because that's the really challenging, really unusual part. I just want to talk about a couple more aspects of the design, and then I'll get on to questions. But basically, the frequency of the vortex shedding, it changes depending on what the wind speed is. So they need to be able to tune the natural frequency of the device so that it changes to match the wind speed. And that is why they said it's challenging to have a really wide operating speed, because to get the natural frequency to match the wind speed at 2 meters per second and then at 20 meters per second is really hard. So on their current version, they go between 3 and 12 meters per second. Okay, here's a good question. How does the cutoff work at high wind speed? So this, I wasn't 100% sure, and they do get into it in their website a bit, but basically the way that the frequency modulation is happening, it's because of the magnets that they've got in there, and it. Yeah, sorry, I'm giving a really bad explanation now and I won't be able to find it on the website. But basically above a certain frequency, then this the magnetic frequency modulation, it doesn't work anymore. And they say it just stops. Above 12 meters per second, it just stops, so that you don't even need a brake or anything. That I was not able to really dig deep into in probably enough depth. So maybe they'll come back to me with some more information. I can share it with you next time. Engineering fail inspired creation of a 100-watt wind turbine. Seems like they have a lot of time on their hands. For now it's 100 watts. It can be scaled up, but I would agree that is it is a lot of effort to get to a 100-watt turbine. Does the vortex shedding frequency change with wind speed? Yes, exactly, it does. And you probably wrote that before I mentioned that. Some more about, natural, examples of resonance in built form in condominiums, tall towers. Okay, and what wind speed does this thing snap and become a lethal projectile? I will get to that later. Actually, that's one of the questions. All right, what kinds of materials they use for these? So I believe it's like a fiberglass shell for the outside. This is all just fiberglass, and then there's on the inside this. Here is the part that's doing all of the heavy lifting, so to speak, and that's carbon fiber. Okay, and so next we've got a question: what coefficient of performance do they claim or demonstrate? And so that actually I didn't calculate that, but it's got a swept area of 1 meter, and at 11 meters per second, you get 100 watts. So you can do that calculation and share it in the comments, maybe somebody. But we are now going to get on to some of the design challenges. So the first one that most people raise, and was the most obvious one to me when I was looking at it, was the fatigue of this component here. I mean, it's just wobbling and wobbling and wobbling and wobbling for ages. And they have said there's a few different varying bits of information on their website. I think that they have updated their website incrementally as they have made changes, so everything's not super consistent. But they've done calculations and simulations that show between 20 and 80-year design lifetime for this component. And I would say that I am really skeptical of that of that, and I would definitely suggest that they do some physical testing. It's actually, I mean, if you've ever seen how a normal wind turbine blade is tested, they do an accelerated lifetime testing, so they can test out as many wobbles as possible, and instead of in a 20 or a 30-year time frame, they can get all of those bends in say 6 months. And with a small component like this one, like this shaft, they should be able to do that in a lab and get that test done really quick. So I would really like to see some real world fatigue modeling done. The second design challenge that I want to talk about with this one is that they have a linear motion that they're trying to convert into electricity, which is in contrast to, normal wind turbines obviously are rotating, and that is by far the more normal way that we generate electricity. Like basically very close to every single way that humans have to generate electricity involves a rotating motion. So, that's how a normal electric generator works. And I did notice that this it shares this challenge in common with wave energy. It's one of the things that we have seen is causing extra problems. Wave energy has a lot of challenging things to deal with, but one of them is how can we get this linear motion and convert it into electricity. So yeah, that's, like I said, that's their most secretive part of their design, the alternator design, and how it is going to make electricity from this linear motion. But I mean, the concept is kind of cool because it doesn't have any wear parts. It's all about magnets moving relative to each other. So it seems like there's the possibility that if they can get it working in a robust way, then it is going to potentially be lower maintenance. And that's really the big thing that they're selling, is that they think that this is going to be really similar to, you have a solar panel on your roof, you don't really need to do too much to it. Whereas if you have a wind turbine in your backyard, then those do require maintenance. And so their goal is that they're going to end up with something similar to that. Okay, and another design challenge I think they have is their low cutout wind speed at the moment. So let me just show that. So at the moment it cuts out at about 12 meters per second, but we know that the amount of energy in the wind increases with the cube of the wind speed. So by cutting out at such a low wind speed, you're really cutting out a lot of all your best times. So you can see that it cuts in at 3 meters per second. And this is something that they share in common with a lot of other small wind turbine generators, new designs. They're often talking about how impressive their low wind speed performance is and how this differs to normal wind turbines. But the fact is, you could make a normal wind turbine to start in 3 meters per second wind if you wanted to, but you don't, because there's such a small amount of energy in the wind there. So you can see that they're generating at 3 meters per second, 3 watts, which the other ones that they have compared to are 0 watts. Honestly, what's the difference between 0 watts and 3 watts? I mean, that's very, very, very low amount of energy, and that's just the reality of a wind resource, is that there's a lot of energy in high winds and not much in lower wind speeds. Okay, then my next issue that I had with the design is the survivability of it. So I think there was a comment earlier about what wind speed is going to break off and kind of fly away. And I did notice that they have said on their website that it can handle 30 to 35 meter per second winds maximum, but that is below even the very low wind speed class from the IEC, which it has extreme 50-year gusts of 42 meters per second. So I think that they need to either increase that limit or by quite a lot, or maybe they can have it be able to fold down and stow in a storm. So those are the main challenges I came up with. Now I just want to read in the comments to see if there are some others from you. So I love this question. If you converted the same area with a stack of small wind turbines, how much more or less power could you generate? Okay, so this is just a really unattractive still shot of myself. This is from the very first YouTube video that I made, and I visited this this farm in Jutland in Denmark, and this is their personal farm wind turbine. It's 11 kilowatts, and that's probably it's like slightly on the high side to run one household off. And then I have. Okay, I hope you can see that. So this is my artistic impression of the 110, the 110 Tacoma model Vortex Bladeless wind turbines that you would need to give you something similar. This one from Philip. Once you go out of sync with resonance, it should stop vibrating. Yes, that's their that's what they're saying is their automatic braking mechanism. And I honestly I don't fully understand what's going on with the magnets inside there to know is that definitely just I've got to stop sharing that screen. Yeah, I don't know because if that is really a fail-safe mechanism, because if you compare it, for example, to if you ever saw those really huge Darius vertical axis wind turbines, they're like egg beater shaped ones, and the common knowledge is that they don't self-start, so they didn't need a brake. But actually, it turned out people found out one day there was a wind, really strong wind at exactly the right angle. It got it started, and then they're like, oh no, how are we going to stop this? So because I don't understand the mechanism of how it stops properly, I'm finding it hard to know, like, is this definitely a safe operation, or could we see, maybe if you double the frequency from, a higher wind speed, does it start up again and just shake itself apart? So that would be, I think that's actually a really good point, that's a big risk. Okay, so how fixed of a base does this need? Can it be put on a tower, or does it need to be fixed to the earth? Somewhere on the website, it does have something about the foundation. That basically it needs to be fixed. And in the communication that I got from their CTO, he said that you can't put it on a flexible roof, for example. It really needs a rigid foundation. But they do. One of their claims is that it needs a much smaller foundation than a regular wind turbine. Here's one. Would end discs not help contain the flow? So do you mean like a end plate, a winglet kind of thing? I'm not sure what you mean there. So maybe you can clarify that somewhere later down in the comments. Yeah, so there's a resonance frequency which causes it to oscillate a lot. Without the resonance, there wouldn't be enough oscillation. The resonance doesn't happen at high wind speeds. Yeah, so that's true. They need the resonance, and then they need to tune the natural frequency to match the high wind speed. So I believe that they could choose, instead of having it go from 3 to 12 meters per second, I think that they could choose to go from 10 to 18. I'm not 100% sure about that, but my from the communication I had with them, I gathered that was a conscious choice because it's made for urban environments which don't have such high wind speeds all the time. So I don't know. I personally think that 12 meters per second cutout is way too low considering how much more power there is available at those wind speeds. I don't see any benefit from making 3 watts at 3 meters per second. Okay, 2 to 3 small vortex generators seems like a much less efficient way to capture the same swept area as a horizontal axis turbine. Yeah, I agree. And then I think I want to move next onto a comparison with other technologies that you could use to do the same thing. So this is a small generator. It's 100 watts maximum. So yes, a rooftop solar panel is probably about 3 times that. So, if you've got 10 solar panels on your roof, then you would need to put 30 of these Vortex Bladeless to get the same peak power output. Of course, you would get some benefit from having both because they're not both generating at the same time, but it is a lot of them. And then if we're going to compare to two regular horizontal axis wind turbines, then a wind turbine with the same height. So, when its blade is in the, so a little turbine, if you look at the height, like all the way up to the top of the tip, you would have maybe a wind turbine blade of about 0.9 meters. And then that would generate 831 watts at 11 meters per second. So that's more than 8 times as much. And if you were going to make a normal wind turbine to make 100 watts, then it would only need a rotor of about 32 centimeters. So yeah, I mean, that's small. It's actually like not drastically bigger than my little desktop model. So that it's a small turbine. It's not going to do a lot unless you have a lot of them. This is cool. From Graham Nicholson. Maybe we should fix magnets to the perimeter walls of high-rise buildings and then install coils around a rigid central lift shaft. I think that if you start a company with that as your technology, I think that you will get lots of media attention and lots of YouTubers making videos about your invention. Okay. So are the parts which need maintenance all next to the ground, or would you need a crane for maintenance? Well, at the moment, it's all close to the ground because they're only 2.75 meters tall. But I did get from the CTO that there's an artist's impression of something that the CTO called a Goliath. And let me just see what he says about that. I asked him, his name's David. I asked David, could you put the device on a tall tower to reach higher wind speeds? And I read that they're working on a larger version with commercial partners. Will that have a taller tower? And he says, that's right. When we talk to large companies, most of them only want to talk about the Goliath Vortex. So that's, this is the Goliath Vortex, 140 meter high machine that we can only build if we stand on the shoulder of giants. And he calls these photos, these images, a dream. And I mean, it does seem like they're a long way away from that. They don't even have the lifetime testing of their original one yet. So I guess with this one, I mean, we would need to go back and have a look. The components are like less than halfway up. I don't know how you would do it for a 140 meter high one. I would guess that we would be folding this part down to access it on the ground, but that's a pure guess. Okay, function for do we have a function for energy capture versus wind speed? I don't have a mathematical function, if that's what you mean, but you can find all that. You can calculate it yourself in this paper. It's got all of the equations that you need to figure that out. And some more details about the tuning system, the magnets and everything. If it's a 1 square meter area, 11 meters per second, 5% weight loss, it's a CP of 13% based on Omnicalc calculator for a VAWT. Is that a website that calculates that? That would be interesting to share that link. I don't know that one. So not a very high CP. And I know every time that I talk about efficiency or power coefficients for wind turbines for urban wind, everybody, like hundreds of people, comment, who cares about efficiency when the wind is free and you're putting it somewhere where you would otherwise not be able, like, it's not like you can put, a 1 megawatt wind turbine in your backyard, like the chance is to get nothing or something. So yes, it's a low CP, and I guess the trade-off is how do you trade off the visual appearance of this versus the electricity that you get? And I know that some people love how these things look, and some people don't like them. So I guess that's the big question. Okay, so the cost, how big forest of these need to match one classic wind turbine? So yeah, like I showed in that little video before, you need to get enough wind energy for a house. You're going to need 50 or 100 of these. And I do actually somewhere, if you go on their website, they do have this questions, comments at the bottom. People can write in, and if you read all the way through there, then you can find lots of extra information. But dude, there is just so much, so you can kind of get lost in there. And I mean, it's really impressive that they're taking the time to answer all these. But I did somewhere pick out the cost that they are saying. The Tacoma is a 2.75 meter high model, and they would love to offer it for about 200 to 250 euros. So they haven't got a manufacturing process yet. So this is just a guess. I'm always super skeptical about energy technologies that tell you that they're low cost, but they haven't actually got a manufacturing process yet. So yeah, I would say take that with a grain of salt, but you can use that. That's the best information that I guess we can have for now. Okay. Height above ground level is low, never good for wind power. Correct, especially in an urban environment. If you get up above all that turbulence, then you're going to get a lot more wind. It's the whole reason why wind turbines are getting higher and higher, and why we're bothering to go offshore, because the wind speeds are higher there. And yeah, because you've got that cubic law of the power in the wind, then it really makes sense to chase the good wind. But that's a negative for urban wind in general. Okay, so here somebody says, no, it's attractive. And heaps of people think that. I mean, but for me, when I, think, do I want one horizontal axis wind turbine, or do I want 100 of these small ones? To me, I really definitely want just the horizontal axis one. But I really like how those things look. So I know a lot of people don't. And I do think it's just a matter of personal preference. Okay. Okay, here's somebody who is saying, I hope the whole resonance thing is eventually going to nanoscale so we can generate usable energy from waste heat, allowing us to break the second law of thermodynamics. You probably know how I feel about trying to beat the laws of thermodynamics. So, you'll never beat the laws of thermodynamics, but it's already possible to use waste heat for other things. That's how combined heat and power works. Heat pumps operate on a similar principle. And there is piezoelectrics and stuff that you can get small amounts of energy from. But in my opinion, all of those systems with piezoelectrics especially, they're just so complicated for really small amounts of energy. So I don't know. I'm not so hopeful about that, but you never rule anything out, I guess. Okay, same commenter. The solar equivalent is assuming you live in an area with good and long sunlight. Australia has a lot of sun, but the Northern EU has wind and little sun. And yeah, that's definitely true. So that is what makes it really hard to make a comparison between how many of the Vortex Bladeless would you need to replace a solar panel. Depends how much wind you've got. It depends how much sun you've got. But you can make those calculations for your own area. If you know what your average wind speeds are, then you can go to their table. And actually, I found a website that will. It's not that one. Yeah, here. It's called Drømstør, which I think means dream big in Danish. And you can put in your power curve and cut in and cut out wind speed, and then you can see how many kilowatt hours you're going to get per year. So you can do this for yourself, but you will find in an urban environment you would need like a real ton of the Vortex Bladeless to make a noticeable amount of electricity. Oh, this is an interesting one. With a sea snake, they have in Orkney, and I think you mean the Palamas, the snake thing that it generated electricity every time it sat on the surface of the ocean, and it made energy every time it bends. And yeah, it is a similar sort of thing. And there's a lot of wave energy devices that are trying to capture when it goes this way or this way. There's a few different linear alternators that have been made. So I did really see a lot of parallels between the challenge that they're trying to solve and also the challenges that wave energy is trying to solve. And then if you also look in the comments, probably if I search wave energy, there's quite a few people that are commenting something similar on the site here. So I think that if they get their alternator working, then they need to apply it to wave energy as well, because I don't know, to me, I think it's really cool how they have developed this this technology. It started with a pretty out there idea. We're going to use vortex shedding and resonance, so we're going to capture it and make electricity from it. And I think that that's really cool. But I think that the real, actual clever engineering thing that they've done that could be applicable elsewhere is the linear alternator. So if that develops in the way that they say that it is, if it really is going to be maintenance free and have this really long lifetime, then you could apply that to a lot of other areas besides just urban wind. This one about the magnets, and this was a question that I had too, but I didn't manage to find the time to answer that. So yeah, I don't know about the magnets and how, if they degrade and how big they need to be and how expensive they're going to be. Okay, then a couple of questions about noise. They say it's silent, and I don't believe it personally, because it's vibrating. But I think I can't imagine how they're going to completely stop all the vibrations from transmitting into whatever it's installed in. There is a video, maybe it's this one, a video where they show it in a wind tunnel, and you can hear the noise, although it's really hard to say what's the wind tunnel noise versus the noise of the device. Yeah. So anyway, like I said, I mean, that could all be just the noise of the wind tunnel. But they say it's silent. Cold fusion is more realistic option than some shaky vibrator. I mean, it's a valid opinion. I don't know. I don't know if I would like to bet on which one is going to be commercialized first. I probably would bet on cold fusion because I think that people are going to keep trying longer. But the Vortex Bladeless does have the advantage of it really does exist. It does what it says. It's just a matter of whether, the engineering of it isn't in doubt. It's what's in doubt is the commercial viability of it. So I guess it's really different to cold fusion in that way. I mean, if cold fusion worked, then it would be commercially great, but will it ever work? I don't know, in 20 years, right? That's the joke, that cold fusion's always 20 years away. So it's another question about optimizing for lower wind speeds, and yeah, they say that a lot. And I just need to go back to this, and I am planning to do a whole video on this at some point, because you can make a wind turbine that works at low wind speeds. Anyone can do that. Any major wind turbine manufacturer, that has a cut-in wind speed of 4 meters per second could easily design it so that it had a cut-in wind speed of 3 meters per second. But if you look at the difference, between 3 meters per second and 9 meters per second, then you've got 30 times more power for the exact same device. Why are we chasing this low wind speed market? What's the point of that? 3 watts, what's that going to do for you? Absolutely nothing. Even if it's 10 times as big, then you're going to get 30 watts. It's not anything useful. Yeah. Okay. Another question about fatigue. We talked about that a bit before, so I won't go into that again. How recyclable the materials in this thing? Have they taken, decommissioning into its design? And it's fiberglass, right? And a bit of carbon fiber. So magnets, I don't know how recyclable magnets are, but I think it would be very similar to other wind turbines. And that's actually another topic that I'm thinking of covering in an upcoming live stream, about all the different work that's underway at the moment to make recyclable wind turbines, because there's been a lot happening in the last 6 months or so since I made some videos on that on my channel. Building a reliable grid level solution with this tech doesn't seem practical. And I agree, and I believe that Vortex Bladeless also agree. If you read their website, they're constantly saying through it that this is not a replacement for utility scale wind farms. This is for distributed energy. It's for households. It's going to make it's small scale. But I do think that that's a really relevant point that a lot of journalists didn't pick up. You know, when you say something is the future of wind, it kind of implies that it's going to make a similar amount of energy to the wind technology that we already have. So I think that comparing it to the normal wind turbines that we have is totally pointless, and it's really a way to, you know, get clicks on your article or on your YouTube video. Okay, it doesn't have much movement. Could you put them extremely densely? So they do cover this on their website, and they say that they think you can put them, the spacing between them should be about half the height, they say. And usually for a vertical axis wind turbine, you'll put like 5 diameters in between them. So yes, you should be able to put them more close together. They haven't done the study on that yet to verify that. But of course, you have to remember, anytime you're putting wind turbines together, I mean, a wind turbine takes energy out of the wind, right? So if you are taking a lot of energy out of the wind, then the turbine behind it is not going to have as much energy left. So if you have a turbine with a 13% coefficient of power coefficient, then you're going to be able to put them to get a lot more closely together than something that has, 50% power coefficient, just simply because there's a lot more energy left in the wind after an inefficient turbine than there is an efficient one. So I would say that's a good general tip to remember when you're looking at. A lot of people are doing studies about packing wind turbines closely together and saying how much closer you can put vertical axis wind turbines or whatever else together. And that's that's something that you have to factor in, is that a wind turbine takes energy out of the wind, so there's less after it. That's just that's the whole point. Okay, so cost is a trade-off. Solar's getting so cheap that I'm not sure this can compete. And so I would say, yes, I don't think even the owners would ever expect, I don't think Vortex Bladeless would ever expect this to get cheaper than solar panels for the rated power. But solar panels do turn on and off all at the same time. So there definitely is some benefit in renewable energy that of different kinds. So I think, yes, that's definitely true. And I think it's also relevant is the fact that batteries are getting a lot cheaper as well. Okay, can we build it from wood, a pine tree? Carbon fiber sounds like overkill for such a funny toy. I bet you could build it out of wood, and it would be cheap to replace that part when it failed. I mean, wood is nature's composite after all. So, why not? Why don't you make one? You can. There's all the information that you need is in this this technical paper. So, I want to see a picture of a wooden Vortex Bladeless generator coming up soon, please. Okay, next. From Alan, would it make sense to disrupt the wind in front of the turbine to increase the turbulence and increase power? Well, thanks for that very tricky question, Alan. I hadn't thought of that, so I don't have anything smart to say about that, I don't think. I don't know if I know that it's not so turbulence dependent as a horizontal axis wind turbine, and that's one of their selling points is, in the urban environment, horizontal axis turbines don't normally go so well because they like all the wind to be coming in a nice, straight stream. And the turbulence doesn't matter as much for Vortex Bladeless. But let's give that to the company and see what they can make of that. From Philip, is it carbon fiber or I guess that you mean glass fiber? And it's both the shaft, the main shaft, the structural bit. This bit here is carbon fiber, and then this shell is fiberglass. And they mention a lot how important it is that this stays really lightweight. So Elon says production is the hard part. I actually don't look at this and think, oh, that's going to be super hard to manufacture. And that reminds me that I wanted to show you this really cool video that they made of their development process. Yeah, so I really love that video because it shows a really good engineering design and development process. I really often get contacted by people who say, I've got this idea and now I just need $1 million to make a prototype. And I mean, that video showed that that's not the way to do it. You don't come up with an idea and then build your 140-meter tall Goliath Vortex Bladeless. You start off with a plastic bottle and a fan to check that the mechanism works, and then you incrementally improve from there. And so I think I really like the process of this and how cool it was that they just saw this destructive power and like, how can we harness that? And then they've gone ahead and done that. So that aspect of it I definitely think is really, really cool. Okay. And more questions from Christopher. If we take urban winds seriously, do we imagine this mounted on a building roof or side? I've occasionally felt strong winds next to buildings. And yeah, I mean, I think we saw in that last video, they had it mounted on a bridge or something, and definitely that's the sorts of places that they're thinking about putting it. Yeah, the thing is, I mean, it's usually quite gusty. Urban wind is very, very challenging. I definitely need to cover that in more depth later on, but it's not so straightforward to get like an economic amount of energy from those strong gusty winds that you feel in urban environments. Here we have a comment about somebody who built a turbine from a repurposed washing machine, and you can definitely do that. I've seen heaps of that on Facebook groups that I'm part of. Why change all winning concepts to get funding? Yeah, I don't know. People are always trying to come up with new things, and I don't want to discourage that. I think we do need innovation. I don't think that we want to have a look, like take a concept like this or any of the other new ones that come along and say, oh, we don't need normal wind turbines anymore because this is going to solve everything. But we do need to keep innovating. So I like this design. I don't believe it's the future of wind turbine, but I don't think it's trying to be. I think that that's just kind of like the really interesting journalistic angle to take. Escal, large pot generator in the base, plant a tree in it, free actuator. Oh, that's interesting. But I don't think I don't know how much the tree would like that, and I don't think that you could tune the natural frequency very easily. Oh, I guess you could tune it still if you've got the alternator. I think still you can tune the magnets in that, but you also have the advantage of the carbon capture of that. So yeah, maybe that's a Mark II, or maybe that's an idea for you to go and pursue. Okay, so I am just going to stop looking at the comments now. I've got through a lot, and I think the live stream's been going on long enough. But I did just want to go through quickly their claims that they made and my response to each of them. So the first claim is that it's distributed energy to compete with solar. That's what they say over and over. And I think, I mean, definitely to me, that's its only real application. I don't believe in the really large Goliath version competing with horizontal axis wind turbines. I mean, can you imagine 140-meter tall thing going like this everywhere? I've really struggled to believe that that's ever going to make cheaper electricity than a normal horizontal axis wind turbine. Okay, second claim, low maintenance, and I do agree that their philosophy is good. They don't have any wear parts. The idea is to not have any wear parts, but they have not got any long-term experience with this, and I think it's a real stretch to call something low maintenance that you have no clue actually how much maintenance it's going to have. I mean, when I design something, I don't design it to be high maintenance. It just ends up that way. It's like you start off with something that's supposed to be zero maintenance, and then as you learn more about the design, then you end up adding in maintenance to, overcome challenging design things. I mean, your car needs, if you've got internal combustion car, that needs so much maintenance, and you would design one that was no maintenance if you could, but that's it's kind of like a band-aid that you put onto engineering design to make up for the realities that you encounter as you develop it. And this isn't developed yet, so we don't know how many maintenance band-aids they're going to need yet. So I wouldn't give any weight to the claim that it's low maintenance yet. Okay, next claim, which is also common for a lot of vertical axis wind turbines, is that it's omnidirectional. So it doesn't matter what direction the wind comes from. And that is true. It's also true that horizontal axis wind turbines are omnidirectional. They have a yaw system that turns the turbine. It is not such a big deal. It's not like one of the critical components that are always failing or adding ridiculous amounts of costs to the wind turbine. Also, small wind turbines can have a tail and self-orient. So it's true that it's omnidirectional, but I actually get really irritated by seeing this like advantage of new wind turbines, especially vertical axis ones that are omnidirectional. Because it's like, yeah, so what? Everything is omnidirectional. Talked a bit about its claim that auto stops in strong wind, and it seems like it has the potential to, but I also do know that, like if you look at some of those really huge Darius wind turbines that they thought wouldn't need a braking system, and then it turned out that it really did. So I think I would definitely put some more effort into evaluating that claim. And then the claim of the visual impact. That is totally a matter of preference. Do you like how this thing looks, or would you prefer to have solar panels and batteries, or a regular wind turbine and batteries, or just get your electricity from the grid? It depends. Yeah, it's just taste. Then they make the claim about birds, which I don't think that they have done any bird studies yet. They mentioned that they are going to work with someone to do a study. I'll be surprised if I ever see the results of that, because a bird study is really expensive. I need to quickly mention that wind turbines don't kill a lot of birds compared to other things like feral cats and cars and skyscrapers. All of those are killing more birds than wind turbines. And it's also always true that a small wind turbine kills less birds than a large wind turbine. So these are small. They're probably going to kill less birds, but because they're small, they're also going to make less energy. They talk about low carbon footprint. Again, they haven't actually made it, so I don't think we can really say about that yet. Low mass. I didn't do the calculation. We could compare it. I mean, it's a small turbine, right? So it's light, but if you multiply it by 8 to get the same power, is it still light? I didn't do that calculation. I suspect that it's not so different. Next claim, small foundation. Again, it's a small wind turbine, so it has a small foundation. Okay, so yeah, that was all of what I want to talk about today. I think an hour is long enough for me to be talking, but I've been really excited about. I thought that I was going to talk to no one today, so I can't believe how many comments I've gotten. It's really awesome. Thank you so much for showing up. I'll read through the comments later and try to I'll respond to your comments and take it on advice for the next live stream. So I am kind of hoping to do these frequently. In theory, I think every 2 weeks, but it's hard for me to commit to that time frame. It's a lot of work to prepare for this. I expect the next one I will. So this one was weird wind. I'll do more in this series, but I think the next one I want to make on strange storage. So maybe if you can think about some weird energy storage systems that you've seen in the news, then comment, and I'll put another post to get ideas about which one we should do and vote on it again. Yeah, I'm just trying to see if I did just want to wrap up about the technology. Like, a lot of new energy techs that we see are really scammy. It's like, this is just a computer simulation. It's never going to actually do what they say. It breaks the laws of thermodynamics. This Vortex Bladeless is not that. This is a real technology. They have been very rigorous in the information that they've shared. The only question is about its commercial viability and does it make a meaningful amount of electricity. But I definitely really appreciate the engineering effort that these guys have gone to. Okay, so I just need to thank again the sponsor, WeatherGuard Lightning Tech. So check out the latest podcast that we did. I put the links in the description to where you can get that podcast. In the latest episode, we talked about, did you see in the news there was a truck with carrying a wind turbine blade crossing the tracks, and it got stuck and it didn't quite get off the train tracks before a train came and smashed into it. So we talk about that. We also talked about drones mapping the seafloor to accelerate offshore wind farm development, and also a little bit about recyclable thermoset resins for wind turbine blades. So you can check that out and sign up for the tech news to get weekly updates on the podcast and curated tech content from the news. Yes. And my next video should be out next normal video should be out next week and be on the topic of lithium mining and how we can make it environmentally friendly. So that's all for today. And thanks so much for joining, bearing with me with the delay. And while I get used to this whole live streaming thing, please leave comments for how I can make it better. And I'll see you in the next one. Bye.